Hello, Mike Pinocchi here with Network Protocol Specialist LLC. In this video, we're going to dig deep into the Wi-Fi capabilities of the NetAlly EtherScope nXG. Let's start with the objectives. Troubleshooting workflow for Wi-Fi. Uploading the Wi-Fi analysis to Link Live. Reviewing the Wi-Fi analysis in Link Live. We've received a problem ticket that says some people are getting slow response time on the guest wireless network. We're assigned the ticket and need to go out and quickly find out what's causing the slowdown. The first step is to go to the auto test application and run an air quality test. This will provide us with an overview of what's happening on the wireless network. In this case, we see that channel 1 is running at 47% utilization. That's pretty high. It looks like things are working well in the 5 GHz band. So let's tap on the channels map and start drilling into channel 1. The channels map gives us a graphical representation of what's happening on each of the channels. Above the graph, we see the number of access points and the number of clients on each channel. Our graph shows us the utilization is high on channel 1, just like we saw in the air quality auto test results. I'm going to tap on the channel. When I do, channel details appears at the bottom of the screen. Tapping on channel details allows me to drill deeper into what's going on channel 1. It's important to note that we are moving from a broad view of the wireless network to a more detailed view as we have more information as to where the problem's located. One of the first things I see is that one problem has been detected for this channel. Tapping on the problem, I see the EtherScope has compared the utilization on channel 1 with the problem threshold limit. Since the utilization on this channel is above that threshold, it's flagged as a problem. For each problem detected, a problem description will be shown, as well as recommendations to resolve the problem. Let's go back and get some more information on what's going on with this channel. Tapping on RF and traffic statistics will display information about the utilization, interference, and retries for this channel. This information can be graphed out over a 24-hour period. In this case, we see that our signal's good, our noise is low, we have a good signal-to-noise ratio. Looking down a bit, we find that the utilization is high and consistent. Our non-802.11 traffic is low, so the cause of the problem is most likely not an interference source. Let's go back and see if we can identify the source of the 802.11 traffic. Tapping on BSS IDs, I can see all of the BSS IDs for this channel and the information about each one. I previously set my sort order to 802.11 utilization. This is done by tapping on the sort field above the list of BSS IDs. I can see that the BSS ID that's handling the guest 24 network is running at a high utilization. This would tell me that someone on the guest network is moving a lot of data and impacting the other clients. Let's find out who it is. Tapping on the BSS ID, I can drill down even deeper and get information about that specific device. As with the channel, I can view the RF and traffic statistics. If we scroll down, we can see the utilization broken out by channel and the BSS ID. This gives us an idea of how much of the channel utilization is coming from this BSS ID. It looks like most of the utilization is coming from this one. Let's go back and see which client is generating all the traffic. I can see there are 4 clients associated with the BSS ID. I'll tap on them to get more information. It looks like the OnePlus phone is generating the majority of the traffic on this channel. I can now tap on that client to graph out the RF and traffic statistics over time. This screen provides me a wealth of information about the performance of the client. Even if we weren't trying to track down a problematic device, we can use this screen to get an idea of how an individual device is performing. Being able to view the transmit and receive rates over time, as well as the retry rates, is critical to being able to diagnose issues with throughput and reliability. Up until now, I've been passively monitoring the network. If I wanted to get more information about this specific client, I could run an auto test to connect to the guest network and let the EtherScope discover the network. This would provide me with the IP address and possibly the name of the device that's using up all the bandwidth. Armed with this information, I can go out and find out what this person's up to. In addition to being able to drill down into the details of the channels, I can use the channel overlap graph to see the channel occupancy and widths in the 2.4 and 5 gigahertz bands. This is a great way to see if there are access points out there that are adversely impacting mine. All of this information I've collected about my wireless network can be uploaded to Link Live. Tapping on the three dots in the upper right corner, I can upload the wireless discovery information to Link Live for documentation and analysis. I'll give it a descriptive name and tap on Save to Analysis Files. Now, if I jump over to Link Live and go to Analysis Files, I can see the uploaded file. Clicking on View Analysis displays the detailed information about the Wi-Fi discovery. Here I can see information about the channels, SSIDs, APs, BSSIDs, clients, and interferers. I can click on the Action button at the bottom right to generate a CSV or PDF report based on this discovery information. Wireless problems can be difficult to diagnose and resolve. This doesn't have to be the case when you're using the NetAlly EtherScope nXG. With the ability to start at a broad level and drill down into the details for each device on the network, you can follow a troubleshooting workflow that will get you to the root of the problem quickly and easily. Be sure to check out the other videos on how to get the most out of your NetAlly EtherScope nXG.